Like the sine rule, the cosine rule is used only with non-right angled triangles. And we use the cosine rule when the sine rule won't work. There's two potential cases that you'll be given in the questions for your course. So the case one is when two sides are known and the angle in between, but we don't know what the third side is. So we don't know what A is here. And we can't use a sine rule to find that because we don't know what either of the other angles is. So just a quick reminder for the sine rule. So the sine rule is sine of the angle A over the side length A is equal to sine of the angle B over the side length B. So we need another angle here to be used to be able to use the sine rule. For our second case down here, we have the three sides that we know, but we don't have any of the angles at all. So we definitely can't use the sine rule here. So again, this is where the cosine rule will come into play. So the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a. So again, this is in the formula tables book, similar to the sine rule. But there's a couple of things we do need to note here. Like I said before, the side lengths are always denoted by lowercase letters, and the angles are always denoted by capital letters. So as you can see here, our capital A is our angle A, and that's opposite our side length, which is A. So they're the two really important ones we need to know. We need to know whatever the angle is that we're looking for. We need to know which one that is, and we need to know which one is opposite that so we can input that into our formula correctly. The other two sides, B and C, in this case, it doesn't matter which one is which. The A is the important one that we need to be able to differentiate just because of the way the formula is. So for our first example, so this is the first case where we are given two sides and the angle in between, and we're looking for that third side. So as you can see, I've drawn an arrow here to show the opposite side to the angle that we were given, so our x, which means that side x is going to be our a in our case for our formula. So we've got a squared plus is equal to b squared plus c squared minus 2bc cos a. So our a is going to be x squared, and that's the one we're going to be trying to find. B and C, it doesn't matter which one it is. You can label them on your diagram if you want. So I'm going to say 8 is B and I'm going to say 10 is C. So this is going to be 8 squared plus 10 squared minus 2 times BC, so 2 times our length of B and C, which is 8 and 10. And then that's going to be multiplied by cos of our angle, which is cos of 50. So what we need to do is to do a bit of tidying up on our right hand side. So this is going to be x squared is equal to 64 plus 100 minus 2 times 8 times 10 is 160 times cos of 50. Tidy this up a little bit more. So we've got x squared is equal to 164 minus 160 cos of 50. Now, at this point, we can use our calculator and figure out what the right-hand side is. However, I'd hold off on this because the majority of the time you can get a decimal, in which case, when we then try to deal with the x squared on this side and we go with our square root, it may give us a slightly different decimal than as we probably will round. So what I would do is leave the right-hand side and deal with our x squared. So to get rid of the x squared, we're going to square root both sides. So we're going to do x is equal to the square root of this whole bit on the right hand side, which is 164 minus 160 cos 50, and then stick that all into your calculator, which should give you the value of x is equal to 7 point, and we're going to 2 decimal places, so 7.82. So that's going to be our distance of x, which is from E to G. Okay. Our second example, which is a case 2. So this is where we were given the three sides and we were asked to find the angle. So very similar to case 2 here. So again, we need to draw our triangle out or if it's not given to us. And we need to identify which side is A for us, so we can put that into our formula correctly. So it's always going to be opposite the angle. So our angle is this times called theta, and we have our opposite side to that. It's going to have a length of 12. So filling that into the formula, we've got A is 12, so 12 squared. Similar to the last one, it doesn't matter which side B and C are, so I'm going to say B is 7 squared, and then D can be the 10. Minus 2 times B and C, so 2 times 7 times 10. And then cos A, so our A, which is our angle, in this case is theta, so I'm going to label that as theta. So tidying all this up, we're going to go 144 is equal to 49 plus 100 minus 140 cos theta. Again, tidied up a little bit more. 144 is equal to 149 minus 140 cos theta. Okay, so now what we were trying to do is we want to get that theta on its own. So what I'm going to do is I'm going to bring this 149 over to the right hand side. So it's going to be 144 minus 149, so changing the sign, is equal to minus 140 cos theta. So that's going to give us minus 5 is equal to minus 140 cos theta. Again, I want to get this right hand side where it's just cos theta. So I'm going to divide both sides by minus 140, so I get rid of that minus 140 on the right hand side. So this is going to be minus 5 over minus 140. Because I'm dividing it, it's going to cancel it out, so this is going to be equal to cos theta. So similar to the last example, I can stick this into the calculator on the right hand side again, but I'm going to hold off just purely so I'm not losing any decimal points in my rounding. So cos theta, if we want to get just theta on its own, I need to inverse cos the opposite side. So that's going to be cos inverse on whatever is in this fraction, which is minus 5 over minus 140. We can simplify that, of course, if you want. I'm just holding off on the calculator work until the end. So stick that into the calculator and we should get, if we're rounding to the nearest degree, so it should be 88 degrees, which is our theta, and that is our angle theta between the 7 and 10 at Q. Okay, so they're the two possible cases that we can be given. Now remember, always try the sine rule first. Cosine rule is a little bit more long-winded than the sine rule, so we only use it if we cannot use the